Hey guys, today we're talking about exponents. So you may have seen exponents before. An example of exponent is if I were to have 3 raised to the second power. Okay, so I could say that this is 3 squared, or I would say this is 3 to the second power. So 3 squared or 3 to the second power. What this means is it's 3 times 3. If I add 3 raised to the third power, I would say that that is 3 times 3 times 3. Notice that there are 2 3s. And notice that there are 3 3s. Now, if I were to do 3 to the fourth power, that would be 3 times 3 times 3 times 3. And you'll notice quickly that there are 4 3s because it's 3 to the fourth power. All right. Let's say I have 3 to the second power here. So that's 3 times 3, which is 9. 3 to the third power is 3 times 3 times 3. So that's 9 times 3. And that's 27. Here I have 3 to the fourth power, which is 3 times 3 times 3 times 3. And that is 81. So there are parts of this that we need to know what they are. There are special terms to describe each part of 3 to the second power equals 9. The 3 is called the base. The actual exponent that we're talking about is this little number up here, and that is called the exponent. And the 9 here, the answer, we call that the power. So the big number is the base. The little number up in the corner is the exponent. And the answer is called the power. Well, let's say I have 4 to the third power. Okay? 4 to the third power is equal to 4 times 4 times 4. Well, if you know 4 times 4, that's 16. 16 times 4 is 64. So 4 to the third power is 64. How about 5 to the second power? Well, 5 to the second power is 5 times 5. And that is 25. But you may see it as -5 inside of parentheses raised to the second power. Now, what this is telling us is that whatever is in the parentheses is being multiplied by itself. So that's -5 times -5. Well, if the signs in a multiplication problem are the same, we have a negative times a negative, that's going to be positive. And we also know that 5 times 5 is 25. Because this sign, we can say it jumps over in here and makes it positive. So that we get 5 times 5, which we know is 25. But if I have negative 5 squared and the negative is not in parentheses, we treat that like negative 5 times 5. And that gives us negative 25. Let's do 6 squared. 6 squared is 6 times 6. And 6 times 6 is 36. But if that 6 is negative inside of parentheses squared, that's negative 6 times negative 6, which is also 36. But if that 6 is not in parentheses, we treat that like negative 6 times 6. And negative 6 times 6 is negative 36. What if we're dealing with an exponent that's not 2? So in this case, I have 5 raised to the third power. So that's 5 times 5 times 5. Well, 5 times 5 is 25 times 5 is 125. But if I have negative 5 in parentheses raised to the third power, that's negative 5 times negative 5 times negative 5. Well, if I do negative 5 times negative 5, that's positive 25 times negative 5. Well, that's a positive times a negative. And when I have different signs, that means my answer is going to be negative. So the answer is negative 125. How about when I have negative 5 raised to the third power and there are no parentheses? Well, then I'm going to treat that like negative 5 times 5 times 5. Well, here I have negative 5 times 5. That's negative 25 times 5. Negative 25 times 5 is also negative 125. Let's say you have something that looks like this. Negative 3 in parentheses to the second power. Well, that's negative 3 times 3. Well, I can do the 3 times 3, which is 9. And this negative sign is going to make it negative. So I'll have negative 9. If I had negative 4 raised to the second power, that's going to be negative 4 times 4. If you'll remember, parentheses like this means multiplication. So 4 times 4 is 16. This negative sign makes it negative. So the answer is negative 16. And that's how you find the power using exponents.